Good afternoon, everybody. Good afternoon. Good afternoon. Hi, NEET Avengers. So nice, nice of you to be here. Hi, Aaditya Mishra, Altaf Jam. My usual crowd is here. Daniel Das is here. Usha Nandani is here. Hi, everybody. Welcome to Momentum with Vedantu, guys. If this is your first time, please like, share, and subscribe to our channel. Okay. Also, at the same time, NEET Avenger is telling me, sir, sir, please send notes for both optics and thermal physics. There is only blank page in the notes that you provide in Telegram. Is it? Is it? I thought I had provided proper notes. I will check NEET Avenger. I will check. Okay, but there are notes there. There are notes there. Okay, I hope there are notes there. But there are. I think there are. I think there are. All right, guys. All right, all right. So, welcome to another session of Momentum with Vedantu. Welcome, welcome, welcome. I had given a question in last class. And we will discuss who gave the first correct answer. But before we get into that, we will just start off with the class. Okay, guys. We will just start off with the class. So today's session is called heat transfer. I think everybody knows what heat transfer is, but people don't know how many modes of heat transfer there are. Do you guys know how many modes of heat transfer are there? There are. If you know, tell me how many number of ways in which we can transfer heat. Okay, if you know, tell me in the chat. Tell me in the chat. Number of ways in which heat transfer takes place. Everybody, tell me in the chat, guys. Tell me in the chat. Do not be shy. मेरा चैट वो हो रहा है क्या? कभी कभी चैट रिफ्रेश नहीं होता है, कभी कभी रिस्पॉन्स नहीं होता है, दोनों में से एक चीज होती है, बट मोस्टली चैट रिफ्रेश नहीं होता है। ओके, वाओ, मेरे अपने वीडियो पे ऐड आ रहा है। क्या बात कर रहा हूँ? हेलो, हाँ, या ओके, देयर आर थ्री वेज, यस, सुप्रिया गुप्ता, आदित्य मिश्रा, मिस्टर बेस्ट, कृतिका विश्वास, एवरीवन इज करेक्ट, देयर आर थ्री वेज, ओके, थ्री वेज, ओके, सो एवरीबॉडी नोज देयर आर थ्री वेज, ओके, या ला, ओके. What are the three ways? What are the three ways? It's everybody knows there is conduction, convection, and radiation. Conduction, convection, and radiation. Okay. Now conduction happens in all three states of matter. Conduction happens in all three states of matter. Okay, solid, liquid, and gas. But most prominently, we talk about conduction in case of solids. Okay, most prominently, we talk about conduction in case of solids. Okay, what exactly is conduction? We will talk about it in some time. But yeah, 18,000 people are watching right now. Oh, Dexter. Yeah, thank you so much. So, next is conduction, convection, radiation. Three modes of heat transfer. Okay, let's talk about each of them one by one. Today we will discuss just conduction. Okay, tomorrow we will discuss radiation. Not tomorrow, day after tomorrow we will discuss radiation, and then we'll move on to the next chapter. Aditya Mishra, it's not 18K. Aditya Mishra, it's not 18K. Okay. Yeah. All right. All right. So today we'll discuss conduction. Tomorrow we will discuss radiation, and then we'll move on to the next chapters. Okay. Now, if you look at this diagram, guys, if you look at this diagram, there are all three modes of heat transfer happening. Okay, when this hot plate gets heated, okay, and when this gets red hot, okay, what is happening is it is going to give out heat in the form of a radiation. ये radiant लिखा है, in the form of radiation. Okay, it is going to give out heat in the form of radiation. This radiation is nothing but electromagnetic waves. Okay, electromagnetic waves that you guys will study in class 12 carry energy with themselves, and when something is super hot, it gives out electromagnetic radiation. Okay, NEET Avenger, I'm good. NEET Avenger, I'm good. Okay, all right. Now, next is if you see here, there is also convection happening. Okay, what exactly is convection? The water at the bottom of the container gets heated and goes up, and the cold water from the top comes down. Okay, and then it gets heated and then goes up, then comes down, then goes up, then comes down. Okay, that is what is happening here in convection. And conduction is basically because this is made up of metal, this metallic handle will get heated. When you heat at this end, the heat will travel through the metal and will heat up the handle as well. Okay, So this is the three modes of transfer. This is the three modes of transfer. So Kaushik, you're not very late. You're not very late. Welcome everybody to class. We're just discussing heat transfer today. We'll discuss conduction. Tomorrow or day after tomorrow, we'll discuss radiation. Okay, so exactly what happens in case of conduction. Okay, so in case of conduction, first of all, we mostly are going to talk about solids in case of conduction. It happens in liquids and gases as well, but it's not very prominent there because liquids and gases, the molecules move around very easily, and so we don't discuss that. In case of conduction, you have to understand that heat transfer does take place. Okay, heat transfer does take place, but matter transfer does not take place. Okay, what that means here is if I have one end of this solid, if I, let's say, I have a solid body here, okay, and I heat one end of this solid, so what happens here is that the molecules will start vibrating. Because they are heated, they will start vibrating, and when they start vibrating, guys, what they will do is they will transfer their vibrational energy to the neighboring molecules. They will transfer their vibrational energy to the neighboring molecules. And as a result, this end will become hot. This end will become hot. So here, if you see, all the molecules will stay in their own position only. They will not move. They will just vibrate about their main position and transfer the energy. Okay. Tamanna Bharadwaj is asking, sir, when will you take daily class? Tamanna, very, very soon, very, very soon. Just as soon as we are done with NEET, I will start daily classes. Okay. Dexter, it's okay. It's okay, Dexter. I forgive you. I forgive you. Okay. All right. So I hope everybody understands what conduction is. Okay, we'll discuss a lot on conduction, but for 2 minutes, let's discuss convection. Okay, because convection is generally not part of the syllabus, but you need to know one or two things about convection. Okay, so first is this. In case of convection, here what happens is that heat transfer takes place. Heat transfer does take place from one end to the other end, but matter transfer also takes place. Okay, matter transfer also takes place from one end to the other end. Okay, what I mean here is that if you're heating water, then the molecules at the bottom surface will get heated. Okay, because of which the water at the bottom surface will expand, because of which its density will decrease and it will start going up. When it gets heated, its density will decrease and it will go up. So here, if you see, heat is getting transferred in upwards direction, but also at the same time water molecules are also traveling in upwards direction. And similarly, when the hot molecules go in the upwards direction, the cold molecules will travel in the downwards direction. Okay, to fill up the gap. The cold molecules will get transferred in the downwards direction. So in this type of current is called convection current. This type of current is called convection current, and this is super complicated to analyze this quantitatively, to do calculations and everything. It's super complicated, so we are not going to get into that. Okay, because it is out of syllabus. Yes, Kaushik, today's notes will be shared. Okay, today's notes will be shared. Okay, Shruti Kumari, the timing right now is from 2 to 3. I will very soon it will go back to its original timetable. Okay, very soon it will go back to the original timetable. All right. Now, also you have to understand, guys, the hot water is less dense and it will rise. The cold water is more dense and it will sink. Okay, this is very simple. Now, you have to understand that convection itself is of two different types. Okay, convection itself is of two different types. Do you guys know what are the two different types of convection? Anybody know? Anybody know? Anybody know? Tomorrow, smart book. Tomorrow there is a class for ray optics, not for convection. Okay, tomorrow no class for conduction and convection. Tomorrow class for ray optics. Okay, okay. Okay, Dhanush finds this time convenient. I think this time is much more convenient than 12 to 1. We will probably keep classes on this time only. Okay, all right, all right. Pratham Patil is asking, sir, if vibration is passing from one atom to another, then atom Then the heat which feel is produced due to vibration. Pratham, yes, the heat that we feel is due to vibration energy of molecules in solid. Okay, that is in case of solids, it's vibration energy of molecules. Ajay Kritik, for NEET physics, the best book that, in my opinion, the best book is just NCRT. You should first of all finish NCRT, then you can do any reference. Okay. All right, guys. All right. Problems on thermal expansion, Kaushik. I will add a homework sheet very, very soon. Okay. Probably tomorrow, probably tomorrow, probably today. Okay. All right. All right. Now, convection, guys. Let's get back to the lecture. Convection is of two different types. What are the two different types of convection? We have something called natural convection and we have something called forced convection. Okay, a natural convection is driven only by heat transfer, is driven only by temperature difference. Okay, what happens is that the water here gets heated up, its density decreases, so hot water rises and cold water comes down. Hot water rises and cold water comes down. This is called natural convection. This is called natural convection. And the second one is forced convection. Forced convection is when the flow is driven by an external factor. Guys, this is very, very simple to understand. This is just a stirrer here. Okay, and I'm stirring the liquid using my own some external factor. Okay, I'm stirring it with my hand or something. So this is called a forced convection. Here, the heat transfer will be better, but what is the difference between the two? What is the main difference between the two? That this natural convection can only happen in gravity. Okay, can only happen in gravity. Why am I saying that this natural convection can only happen in gravity? Why am I saying that? Why am I saying that? Because when the hot water is rising up and the cold water is coming down, it's because of difference in density. Okay, the cold water feels more heavy, the hot water feels less heavy. So because of that, the cold water is coming down, but that heaviness is only there when you are on Earth. If you go out to the International Space Station, then there is no gravity there. And in that case, the natural convection will not happen. Okay, in that case, the only type of convection that you can have is forced convection. Okay, Josh is asking, sir, when heat transfers, in case of heat transfer, do all atoms vibrate at the same rate? No, Josh, that is not exactly true, and that is not exactly part of the syllabus as well. Okay, don't go in that direction. If you go in that direction, we have to go deep into theory, which is not going to help us in any way. Okay, but no, the answer to the question is no. Next is radiation. Now everybody knows that there is a, where there is radiation, when the energy from sun comes to earth, there is a radiation. This is heat transfer through EM waves. Okay, heat transfer through electromagnetic waves. Okay, electromagnetic waves. And in this case, heat transfer through electromagnetic waves may mainly when we feel the heating effect, we are talking about infrared radiation. Mainly when we talk about heating effect, the waves which cause intense heating effect is infrared radiation. Okay, and here no material medium is required. Okay, no material medium is required. Okay, why? Because this can transfer to the radiation heat transfer can occur through vacuum as well. Okay, it can occur through vacuum as well. Okay, Shruti Kumari, natural convection and free convection are the same thing. Yes, you are correct. This is called free convection. Okay, and forced convection is different. Forced convection is different. Okay, all right, guys. I hope everybody understood. I hope everybody understood. Okay, all right. Now let's go to the main thing for today's class, what we are going to discuss today, and that is conduction. That is conduction. Now, in order to understand conduction, guys, let me first talk to you a little bit about some other topic which you have studied in class 10th. Okay, you must have studied a topic like this in class 10th. What is this topic called? It's called current electricity. Okay, this topic is called current electricity. Let's say I have a resistance here and I have a battery here, then what will happen is there will be current through this battery, and the value of that current will be equal to what? V divided by R. Everybody knows this. This current, by the way, can also be written as a rate of flow of charge, the amount of charge flow divided by the amount of time taken. Okay, everybody knows this. Everybody knows this. Yeah, Tharva Sharma definitely knows this. Okay. Yep, definitely, definitely. Look at his excitement. Oh my God. Oh my God. Okay, now also at the same time, guys, you have to remember, if I have a resistor here between 2 points, okay, if I have, let's say, a resistor of 2 ohms here, okay, and I am maintaining both these ends at different potentials. Let's say I'm maintaining this at 10 volts and I'm maintaining this at 4 volts. Okay, then in this case also there will be current. In this case also there will be current, but you have to remember how the current will be. Current always goes from higher potential. The current always goes from higher potential, okay, to lower potential. The current always goes from higher potential to lower potential. All right, I hope everybody understood. The current always goes from higher potential to lower potential. So in this case, the current will be in which direction? The current will be in this direction. I. Okay, and the equation is still valid, guys. Equation is still valid. V is still equal to I into R. But you have to remember that here V is not supposed to be potential. V is supposed to be potential difference. V is supposed to be potential difference. Okay, so in this case, when I write V is equal to IR, I have to take actually the difference of potentials. I have to write 10 minus 4 is equal to I into 2. Okay, 10 minus 4 is equal to I into 2. It's potential difference, which gives me I is equal to 6 by 2, which is 3 amperes. Okay, I is equal to 6 by 2, which is 3 amperes. I hope everybody can see this. Everybody understands. In this case also there will be current, and current always goes from higher potential to lower potential, guys. Current always goes from higher potential to lower potential. I hope everybody understood. If you did, please give me a thumbs up. Please give me a thumbs up. Okay. Now, next is there is an there is a lot of similarities between this is charge conduction. Okay, this is called charge conduction. Okay, or electric conduction. Okay, and heat conduction. There is a lot of similarities between electric conduction and heat conduction. Okay, let's say I take a rod here, okay, a metallic rod or something, and apply two different potentials here. Okay, I take a rod here and apply two different potentials here. I keep this as positive terminal, I keep this as negative terminal, or basically higher potential and lower potential. Then there will be current through this. Okay, in this case, what type of current will this be? What type of current will this be? This current will always be the electrical current. Okay, given by delta Q by delta T. Here delta Q is supposed to be the charge flow. Okay, the charge flow. Similarly, if I take a rod like this and keep it at two different temperatures, then here, what will happen? There will once again be a current. Okay, and what will be the direction of current, guys? What will be the direction of current? The heat current, oi, oi, oi. The heat current also goes from higher potential, not higher potential, from higher temperature, okay, to lower temperature. temperature. The heat current goes from higher temperature to lower temperature. In this case, if this temperature is higher and this temperature is lower, then there will be a heat current from left to right, from heat current from left to right. And this heat current similarly is written as delta Q by delta T. In the second case, delta Q is basically the amount of heat flow, the amount of heat flow. Okay, I hope everybody understood. I hope everybody understood. Really, 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 really hope everybody understood. Okay, now what is the similarity, guys? What is the similarity here? Let me tell you what is the similarity. One second, huh? Let me tell you what is the similarity. So, if I have a normal electrical resistance, okay, and potentials V1 and V2, then there is going to be an electric current here. Okay, and I can write here V is equal to IR, or in this case V1 minus V2 is equal to I into R. Similarly, in case of a rod which has two different temperatures on different sides, okay, let's say this temperature is T1 and this temperature is T2, this rod will have a heat current here. This rod will have a heat current here. Okay, and here I will write what? Here I will write T1 minus T2 is equal to H into thermal resistance. Okay, T1 minus T2 is equal to H into thermal resistance. What is RTH, guys? This is called thermal resistance. Okay, RTH is called thermal resistance. And what is R here? What is R here? R is called electrical resistance. Okay, electrical resistance. So if you know a current electricity chapter, it's very simple for you to understand. It's very simple for you to understand heat transfer, heat conduction. Okay, sir, what is Kirchhoff law? Varun Shastri is asking, sir, what is Kirchhoff law used for? Varun Shastri, Kirchhoff's law is used for conduction as well as radiation. There are two different Kirchhoff's laws. We will get to both of them. Okay, have some come back here once again. We will get to both of them. Okay, we'll get to both of them. We'll get to both of them. All right. Now, let's talk about this thing. We know electrical conduction, but let's talk about the heat conduction in a little bit more detail. Okay, in a little bit more detail. Now, here, let's say I have a metallic block like this. Let's say I have a metallic block like this. Okay, and I have maintained it at two different temperatures. I have maintained it at two different temperatures. The higher temperature is T2 and the lower temperature is T1. Then heat will flow from higher temperature to the lower temperature. Heat will flow from higher temperature to the lower temperature. Now we did a lot of experiments. We did a lot of experiments, and this is what we found experimentally. Okay, this is what we found experimentally. Everybody should see this. Okay, everybody should see this. What we found experimentally is that the amount of heat flow, Q, is directly proportional to the cross sectional area A. The more the cross sectional area, the more heat transfer will take place. I think everybody understands this. Everybody understands this. Kaushik is asking, sir, Mendy is there this week? Kaushik, I'll get back to you on that. I think probably there will be a normal session, not Mendy. Okay, and secondly, guys, secondly, what we found is that the heat transfer is proportional to the temperature difference. The more the temperature difference is there, the more the heat will be transferred. Okay, the more temperature difference is there, the more heat will be transferred. I hope everybody understood. I really hope everybody understood. Okay, this is, by the way, how do we found this? We found this experiment karke. And it makes sense. It makes sense. If the difference is higher, more heat will flow. If the difference is higher, more heat will flow. Okay, if the area is higher, more heat will flow. But next thing what we found experimentally is that the amount of heat transfer is inversely proportional to the amount of heat transfer is inversely proportional to the length of the conductor. The amount of heat transfer is inversely proportional to length of the conductor. Okay. I hope everybody understood. I really hope everybody understood. Okay, यहाँ पर somebody is asking, sir, what is H and what is Q? Okay, Q is, my friend, it's the amount of heat transferred. Okay, amount of heat transferred. And what is H? H, my friend, is nothing but the amount of heat transferred per unit time. The amount of heat transferred per unit time. Kaushik, did you understand the difference? If you did, please say yes. Okay. The bad one is saying, sir, in notes annotations are not present. Are you talking? Are you serious? Are you serious? I thought in the notes annotations are present. They're seriously not present? God. Okay, part one. I will upload the notes. I will upload it with annotations. I will upload with annotations. Okay. I'm sorry. I thought they were present because I saved them with annotations. I thought they were present. Okay. Alright, the bad one. Alright, I will give you. I will give you. Okay. Now, one final thing you also have to remember. One final thing you also have to remember. Let's say I was looking at this experimental setup. Okay. So in this case, the more time for which I look at this setup, the more heat will be transferred. This is very, very obvious for everybody. I understand. I hope that if I look at it for 2 minutes, some amount of heat will be transferred. If I look at it for 4 minutes, the double amount of heat will be transferred. The more time for which you look at this, the more heat will be transferred. Or what I can say is that Q is also proportional to T. The more the time you look at this experiment, the more heat will be transferred. Okay. Kaushik is saying annotations are present. Okay. Bad one is saying not present. Oh my god. Okay. Wow is saying, sir, the dimension of Q and H should be same. Wow. It should not be same. How will the dimension of H and Q be same? How will the dimension of H and Q be same? You see here, it will not be same. It will not be same. Okay. The heat current will be joules per second and heat will just be joules. Now, guys, if I combine all of this, what will I get? What will I get? Let's change the layout to blank. What will I get? I will get Q is proportional to A into T2 minus T1 divided by L into T. A into T2 minus T1 divided by L into T. Okay, Atharva Sharma, Kritika Viswas, I will send the notes again. This time I will upload the PDF. I think in the PDF you will find the annotations. I don't know, it's probably because you have either previous version of PPT or something else. That's why you're not able to see the annotation. Okay, in MS Word they are present. Yeah, they should be. Okay, I will send. They should be present, but in PDF they will definitely be present. Okay, all right. So if I want to remove the proportionality, if I want to remove the proportionality, what do I have to add? What do I have to add? What do I have to add? I have to add a constant. Okay. And that constant in this case, guys, that constant in this case has a special name. It looks like K. It looks like K, but it's not exactly K. Okay, it looks like K, but it's not exactly K. This is the Greek letter. This is a Greek letter. Okay, and this Greek letter is called kappa. Kappa. It's a Greek K. Okay, that's a Greek ma. A is alpha, B is beta, where K is kappa. Okay, and this K, the scientific name of this K is, it's called the thermal conductivity of the material. Thermal conductivity of the material. Thermal conductivity of the material. I hope everybody understood. Mahendra Pal, my friend, what happened? Which part did you not understand? Which part did you not understand? Okay, tell me. Alright, Mahinder, see, I have, if you look at this, what you will realize is that the experimentally what we found is the more the area is, the more heat will be transferred. The more the temperature difference, the more heat will be transferred. The more the length, the less heat will be transferred. Because in this case, if the length is increased, what happens is that heat has to travel a higher distance. Okay, so more length means less heat transferred. Okay, and so Q is proportional to inversely proportional to D, and the more time you look at this, the more heat will be transferred. Okay, so I combine all of them and I get this equation. I remove the proportionality, add a constant, and get this. Okay, now this K is called kappa, and if I want to find out the heat current, then heat current is nothing but Q by T. So if I substitute the formula for Q, that will be K kappa. Okay, A T2 minus T1 into T divided by L whole divided by T. Now, if you see T and T will get cancelled out, and I get a nice equation. H is equal to K A by L into T2 minus T1. A by L into T2 minus T1. Can you guys see this? Now compare this with the idea that we had developed before. What was the idea that we had developed before? That if I have a conductor here, higher temperature, let's say T2, lower temperature T1, then there will be a heat flow from higher temperature to lower temperature, and I can write this T2 minus T1 as RH into thermal resistance. Okay, compare that to the formula that we just derived. If I have a conductor, okay, with area of cross section as A, one temperature T2, other temperature T1, and there will be a heat current here. Okay, if the length is L, what formula did I get here? I got the formula H is equal to Ka by L into T2 minus T1. From this, if I rearrange this a little bit, guys, see if you can see the similarities. If I rearrange this a little bit, what do we get? T2 minus T1 is equal to H into L divided by Ka. T2 minus T1 is equal to H into L divided by Ka. Can you see this? Yes. In Malayalam, kappa is tapioca. Very good, Jay study. Very good. I did not know that. Okay, Arul Das, this is the session number. If you can see in the chat, it's session number 4. Okay, so we have completed 3 more sessions before this. Now, if you compare these two equations, guys, what do you get? You get the thermal resistance of any body as L divided by K into A. L divided by conductivity into area of cross section. This is an important formula and everybody should remember. This is an important formula and everybody should remember. Here you have to remember this is the length along the direction of heat current. Okay, the length is supposed to be along the direction of heat current. The area is supposed to be in the direction perpendicular to the heat flow, and K is the thermal conductivity, and this is a material property. Okay, what do I mean by material property? If you take iron in India or you take iron in Canada, both places the conductivity of that iron block will be same only, because when we say that it's iron, its conductivity becomes fixed. Okay, if you take any material, its conductivity remains fixed. It doesn't matter what its length is, it doesn't matter what its area is. Okay, nothing. Okay, Abhyuday, hi Abhyuday. Okay. Sir, K is different for different elements. Yes, for different types of elements, K will be different. Okay, for metals, K will be very high. For non-metals, it will be low, because in case of metals, we have something called free electrons, and they are very good at conducting heat as well. Okay, so let's do this. It's a very simple question. Very simple question. I have a block. And I have to find the thermal resistance of the block. Okay, I have a block and I have to find the thermal resistance of the block. Okay, now what are the three cases which are given to us? First, let's forget about these two. Okay, first let's forget about these two. You know what? Yeah, in the first case, let's just forget about these two. Okay, let's say the heat is flowing from left to right. If the heat is flowing like this, guys, if the heat is flowing from left to right, then in that case, what you will say is that the length will be equal to 5L, because length will be length along the direction of heat flow. ओके सक्षम यार, तेरी बात का रिप्लाई कैसे करूं, मेरे को पता ही नहीं तुमने क्या लिखा है. ओके, एंड व्हाट विल बी द एरिया ऑफ क्रॉस सेक्शन, गाइस? द एरिया ऑफ क्रॉस सेक्शन विल बी दिस area perpendicular to the heat flow, so that will be equal to L into 3L. Here, if I ask you what will be the thermal resistance, then the thermal resistance will be nothing but L by K into A, which will be equal to 5L divided by K into 3L square. Okay, which gives me thermal resistance as equal to what? Thermal resistance as equal to 5 by 3KL. Okay, this is if the heat is flowing from left to right. Let's look at the next case, guys. Let's say I have one more case. Here the heat is flowing from top to bottom faces. Let's say here the heat is flowing from top to bottom faces. Now in this case, the heat is flowing in this direction, guys. The heat is flowing in this direction from top to bottom. So in this case, if I ask you how much will be the length L, that will just be equal to L, because I have to take the length along the direction of heat flow. And if I ask you how much will be the area of cross section, then the area of cross section in this case, guys, will be this. This is the area perpendicular to the direction of heat flow. So that will be equal to how much? That will be equal to 3L into 5L. Okay, so if I ask you how much is the thermal resistance, that will be L by Ka. That will be equal to L divided by K into 15L square, or I get R thermal is equal to 1 by 15 KL. Okay, you have to remember, if direction of heat flow changes, then the value of thermal resistance also changes. If the direction of heat flow changes, the value of thermal resistance also changes. If you understood, please give me a thumbs up. If you understood, please give me a thumbs up. Okay, the last one is when it goes from front to back faces. Okay, if it goes from front to back faces, forget about the first two. So where is the heat flowing? The heat is flowing like this. Okay, here the L will be equal to 3L, and area of cross section will be area perpendicular to the direction of heat flow. So that will just be equal to 5L into L. Okay, which gives me RTH as equal to, after some maths, 1 by, sorry, not 1 by, 3 by 5KL. After some maths, you will get this. Okay, I hope everybody understood. The value of thermal resistance also depends on the direction of heat flow. I hope everybody understood that. Really hope everybody understood. Okay, now this is a question. This is a very simple question, and we are going to do something. We are going to solve this question. Now, if you read this question very slowly, some things are given here. Okay, some things are given here. I have a rod of length 0.5 meter. Very good. And we are given something like this. we are given something like this. Okay, what is this? What is this? They have named this something called the temperature gradient. They have named this something called temperature gradient. Now everybody should know what that means. I haven't told you what that is, and I'm going to tell you right now what that is. Okay, so I have a rod with this length, with this temperature gradient, and the temperature of the hotter end as 30 degrees Celsius. You have to find the temperature of the cooler end. Okay, you have to find the temperature of the cooler end. So guys, what exactly is temperature gradient? Okay, what exactly is temperature gradient? If I have a rod, if I have a rod, let's say at higher temperature TH and at lower temperature TL, and having a length L, okay, then the temperature gradient is defined as higher temperature minus lower temperature divided by the length of the rod. Higher temperature minus lower temperature divided by length of the rod. Do you guys understand? This is the definition of temperature gradient. You have to remember this definition. This is what it's called. Okay, so now in this question, if you see, this length is given as 0.5 meters. Okay, and the higher temperature is given as 30 degrees Celsius. The lower temperature is asked to us. Okay, and the value of this temperature gradient is given as 80 degrees Celsius per meter. Okay, its value is given as 80 degrees Celsius per meter. So what will you do here? What will you do here? You will, idhar aaja. What will you do here? You will just substitute all the values. Okay, you will just substitute all the values. What you will write is, what you will write is 80 is equal to 30 minus TL divided by 0.5. This gives me 40 is equal to 30 minus TL, or TL is equal to 30 minus 40, which is minus 10 degrees Celsius. Okay, this is a gradient with respect to distance. Okay, this is not gradient with respect to time. Okay, I hope everybody understood. Whenever it is with respect to time, it's called rate. Correct the bad one. You are right. Whenever it is with respect to time, it's called rate. Here, if it's called a gradient, you have to remember it's the temperature change as you go from one side to the other side. The change in temperature as you go from the one side to the other side. Okay. Whoa is asking, sir, why you didn't convert into Kelvin? Whoa. I did not convert it into Kelvin because I did not need to. You have to remember here, if I'm talking about difference in temperature, if I'm talking about difference in temperature, okay, then difference is temperature is the same in both Kelvin and degree Celsius. Same in both degree Celsius and Kelvin. Okay, because I hope I hope you understand why that is. Okay, I have covered that in the first lecture of temperatures. Okay, temperature scales. All right. So remember, whenever there is difference in temperature, you do not really need to convert it into Kelvin. Alright guys, let's do one more question. Let's do one more question. I have two rods A and B. I have two rods A and B which are of equal lengths. Their ends are kept at the same temperature, and the area of cross sections are A1 and A2, and their thermal conductivities are K1 and K2. Okay, there the rate of heat transmission in the rods will be equal if which of the following is true. Now guys, I want you to read this question. I want you to give this question a try yourself. Okay, I'm going to give you 1 minute to solve. Everybody should be able to solve this question by themselves. I'm going to give you 1 minute to solve. Everybody. Everybody should be able to solve this question. Give me the answer in the chat, guys. Give me the answer in the chat. Everybody should be able to. Whoa, 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 whoa is saying option B. All right, let's see if anybody else also get the answer. Whoa, 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 whoa is saying option B. RL and Kaushik is saying option B. Okay, let's see about others. Let's see about others. Tell me, guys. Tell me. Josh is saying option B. Shruti Kumari is saying option B. All right. Let's see how to solve. Let's see how to solve. Mahinder Pal is saying option B. Very good. Very good. How to solve this, guys? How to solve this? Okay. Now it's better if in all the cases you make diagrams. Okay. So let's say in the first case, I have temperatures T1 and T2. Okay. And I have a rod. Okay. Of area A1, conductivity area A1. One second. Area A1. Okay, conductivity K1, okay, and length L. Okay, now here I can write heat current as H. I can write first of all the thermal resistance. I can write first of all the thermal resistance RTH. Thermal resistance RTH will be nothing but L divided by K1A1. Okay, and I can write T1 minus T2 is equal to H into L by K1 A1. Okay, L by K1 A1. I hope everybody understood. I hope everybody understood. Next what I will do is I will do the same thing. I will do the same thing for the second rod. Okay, if I write down the same thing for the second rod, let me remove this. Let me remove this. Okay. Okay, for the second rod also, guys, if you see the temperature difference is supposed to be same. This is supposed to be T1, this is supposed to be T2, and the rod is supposed to be in between them. Now here the area of cross section is A2 and conductivity is K2. Okay, but here the length is still L and the heat current is still the same. So here what I can write is T1 minus T2 is equal to H into L by K2A2. Now, if you see in both these cases, H is same. Okay, in both these cases, if you see equation, let's call this as equation 2 and let's call the first one as equation 1. Okay, you can just divide, you can just compare these two equations, and what you will get is you can just compare these two equations, and what you will get is that H into L by K1 A1 is equal to H into L divided by K2 A2. Okay, which gives me finally just K1 A1 is equal to K2 A2. Okay, very simple, guys, very simple. It will be option B. I hope everybody understood. If you did, please give me a thumbs up. If you did not, please give me a thumbs down. Okay, you have to give me thumbs up or thumbs down, both of any one of those, any one of those. Okay, now next topic. Before we go into the next topic, everybody has to tell me something called series and parallel combination. Okay, now if I have, let's say, two resistors in series, if I have two resistors in series, okay, one second. R1 and R2. Okay, in this case, first of all, if I ask you what will be the equivalent resistance, can you tell me what will be the equivalent resistance? What will be the equivalent resistance? The equivalent resistance will be equal to, R1 plus R2. Okay, this is the one thing you have to remember in case of a series resistance. And the next thing you have to remember in the series resistor is that if the current here is I, then the current here will also be I, because the current will be same everywhere on the same branch. Okay, so I have to write here, very, very important. Okay, this thing is very, very important. Current is same in both resistors. Current is same in both resistors. I hope everybody sees this. I hope everybody sees this. Okay, super important, super important. Okay, and guys, let's say this point was at potential V1, this point was at potential V2, and this point was at potential V3. Okay, so I can write what? I can write what? If you guys remember, we had this equation V is equal to IR. Okay, from this I can write I is equal to V by R. Okay, and use this in the next page. If I use this in the next page, I can write I. Okay, please see this, huh? This is the important bit. This is the important bit. Everybody pay attention. I can write I as equal to, I can write I as equal to the potential difference divided by resistance. Okay, and I can write this also as equal to the potential difference divided by the resistance. Okay, and I can write it also as equal to the total potential difference divided by the total resistance. Okay, what is the total potential difference, guys? Can you tell me in chat what is the total potential difference? What is the total potential difference? Can anybody tell me in chat what will be the total potential difference? That will be the potential difference between these 2 points. Okay. What will be the potential difference? The total potential difference, it will be equal to V1 minus V3. Okay, I hope everybody understands. It's always higher potential minus lower potential. It's always goes, remember this guys, the current always goes from higher potential to lower potential. The current always goes from higher potential to lower potential. Okay, I hope everybody understood. My voice is coming or not coming? Is my voice coming, guys? If it is not, please tell me in the chat very quickly. Narendra Dwivedi cannot hear me. Is my voice coming? Is my voice coming? Am I audible? Am I audible? It is coming. Yes, it is coming. Narendra, please refresh. Please refresh. Then I am audible. Then I am audible. Okay. All right, guys. I hope everybody sees this. Okay. Similarly, guys, if you have two resistances in parallel, okay, you have to remember this. If you have two resistances in parallel, okay, let's say this is R1 and this is R2. Okay, so the first thing you have to remember here is that 1 by R equivalent is equal to 1 by R1 plus 1 by R2. I think everybody knew this. I think everybody knew this. Okay, the next thing you have to remember is that the current here will be different in both the branches. Okay, let's say the current here is I1, let's say the current here is I2, the current here is I. Okay, so the second thing you have to remember is current will be different in both the branches. You will write I is equal to I1 plus I2. I is equal to I1 plus I2. Narendra, my friend, please increase your volume or something. I think there is a problem with on your side because other students can hear me. Okay. Finally, guys, finally. Okay, remember this equation as well. Okay, I is equal to V by R. I is equal to V by R. Let's apply that here. Let's say the potential here is V1 and potential here is V2. Then, guys, what I can write is, okay, very simply remember this. I1 will be equal to V1 minus V2 divided by R. I2 will be equal to V1 minus V2 divided by R. Okay, and the total current can be written as V1 minus V2 divided by R equivalent. I can be written as V1 minus V2 divided by R equivalent. Guys, if you understood all these three equations, all of them, फटाफट से मेरे को ऐसे thumbs up दे दो so that everybody understands. I hope everybody understands. I hope everybody understands. ओके समझ आया तो फटाफट से ऐसे थम्स अप दे देने का मेरे को पता चलेगा कि अच्छा समझ आ गया भूमिका अंडरस्टूड सुरेंद्र सिंह अंडरस्टूड वेरी वेरी गुड गाइस वेरी वेरी गुड ओके so now just like how we have series and parallel of electrical resistors, okay, we also will have a series and parallel of thermal conductors or thermal resistors. Okay, we will have series and parallel of thermal conductors and thermal resistors. Now, if I have a series combination of various resistors, let's say I have the first resistor, the second resistor, third, fourth, fifth, sixth, seventh, eighth, and nth resistor, okay, then you have to remember the equivalent resistance will be equal to R1 plus R2 plus R3 plus R4 plus dot plus Rn. It will be same as a series combination of resistors. I hope everybody understood. Next thing you have to also remember, that current will be same everywhere. The current here will be same as the current here. It will be same as the current here. It will be same as the current here. Current will be same everywhere. Current will be same everywhere. Okay. Also at the same time, you have to remember that current will be equal to T1 minus T2 by R1. Okay, temperature difference divided by resistance. Okay, just like how we had in electrical resistors. Okay, potential difference divided by resistance tha yahan pe. Here we will have temperature difference divided by resistance, and this will also be equal to T2 minus T3 divided by R2, and this will also be equal to, overall it will be equal to T1 minus Tn divided by R equivalent. Okay, T1 minus Tn divided by R equivalent. The same thing that is there for electrical conductors is also there for heat conductors. I hope everybody understood. Okay, if you did, very good. Give me a thumbs up if you did. Okay, alright, alright. Now, let's talk about parallel combination, guys. This is once again the same as parallel combination of resistors. Here, all these ends, okay, are maintained at temperature T1, and all these ends are maintained at temperature T2. Okay, here the heat currents will be different in all of them, H1, H2, H3, H4, and so on and so on. Okay, just like in case of a resistor, the currents are different. Okay, here also the heat currents will be different. Okay, but first here if you see the resistances where, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Here also 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3 plus dot plus 1 by Rn. Okay, I hope everybody understood. Similarly, I can write H1 is equal to T1 minus T2 by R1. H2 is equal to T1 minus T2 by R2 dot. Hn is equal to T1 minus T2 divided by Rn, and I can also write the total current H as H1 plus H2 plus dot plus Hn, and also at the same time I can write the total current as T1 minus T2 divided by R equivalent. The same thing. Yes, yes. In heat, the temperature is analogous to voltage. In the heat, the temperature is analogous to voltage. There we have potential difference. Here we have temperature difference. There we have electric current. Here we have heat current. There we have electrical resistance. Here we have heat resistance. I hope everybody understood. Okay. Now, let's say this is the first question. Find the temperature at the two junction point. I have one surface which is maintained at temperature 100 degrees Celsius. Second surface which is maintained at the temperature 0 degrees Celsius. And I have two conductors in between. Okay, three conductors in between. Length L and conductivity K, 2K length. Let's assume this is also L. Let's assume this is also L. Length L, conductivity K, length L, conductivity 0.5 K. You have to find both the uh, junction temperatures. Okay, you have to find both the junction temperatures. Now, how do you do this, guys? How do you do this? It sounds hard, but it's not hard. Okay, first thing is first thing is take a burp. Then second thing is calculate the thermal resistances of all the three rods. Okay, calculate the thermal resistances of all the three rods. Can you calculate thermal resistances of all the three rods? Yes, you can. This will be L divided by 2K into A. This will be L divided by K into A. Okay, and this will be L divided by 0.5 K into A, or this will just be 2L divided by K into A. Okay, now if I call this, just for simplicity, let's call this as R. If I call this as R, this will become 2R and this will become R by 2. Do you guys see this? I am calling L by Ka as R. Then 2L by Ka will become 2R and L by 2Ka will become R by 2. Okay, I hope everybody can see this. I hope everybody can see this. Okay, now next, guys, remember what we have to do next. You have to know that when they are connected in series, then in that case, the heat current is same in all of them. So what equation can I write, guys? What equation can I write? Let me just remove this for 1 minute. Okay, this is coming in my way. This is coming in my way. I don't like this. I don't like this. I don't like this. Okay, so what equation can I write, guys? The equation that I can write is H is equal to, let's call this as T1 and T2. Okay, I don't like this. Huh. H is equal to 100 minus T1 by RA. H is also equal to T1 minus T2 by RB. H is also equal to T2 minus T0 divided by RC. And also H is equal to 100 minus 0 divided by R equivalent. 100 minus 0 divided by R equivalent. If you understand how I got this, you have to remember V is equal to IR. So I is equal to V by R. Here instead of V, I have P. Okay. If you understood, guys, give me a thumbs up. Oh, sorry. Instead of 100, I wrote 10 here. Okay, if you understood, give me a thumbs up in the chat. If you understood, give me a thumbs up in the chat. Give me a thumbs up, give me a thumbs up, give me a thumbs up. Okay. Delhi boli ki it should be 100. So I made it 100. Okay. I hope everybody understood. Okay. Now you just have to substitute all the values here, guys. You just have to substitute all the values here. You know that R1, RA, RB, and RC are what? Okay. RA is R by 2, RB is R, and RC is 2R, and this will be equal to R equivalent will be equal to R by 2 plus R plus 2R, that is equal to 7R by 2. Okay, if I'm not wrong, yes, that will be 7R by 2, so it will be 7R by 2. I hope everybody understood. I really hope everybody understood. Okay, now what do I do next? What do I do next? Next, what I will do, guys, is I will equate this with this to find T1. I will equate these two to find T1. Okay, so when I do that, 1 second, give me a blank slide, guys. Yeah, so what I can write is 100 minus T1 upon R by 2 is equal to 100 minus 0 upon 7R by 2. Okay, first if you see R gets cancelled out, 2 gets cancelled out, I get 100 minus T1 is equal to 100 by 7, which gives me T1 is equal to 600 by 7, degrees Celsius. I hope everybody understood. Very, very, very simple. Very, very, very simple. Okay. Similarly, guys, similarly, if I want to calculate T2, what I will do is I will equate this with this. I will equate these two together now. Okay. To calculate T2. So what I will get, guys, now is that T2 minus 0 by 2R is equal to 100 minus 0 upon 7R by 2. Okay, and if you see here, once again, R and R gets cancelled out. This 2 and this 2 will not get cancelled out. Okay, so please do not cancel both of them out. Okay, what I get is T2 by 2 is equal to 200 divided by 7, or T2 is equal to 400 divided by 7. Guys, I hope you understood. Did you understand? Did you understand? Tell me you understood. Tell me in the chat. Give me thumbs up. Give me thumbs up. Fatafat say. Did you? Yes, you did. You did. All right. So if you understood, very good, guys. This is where I will end today's class. But before ending, I want to give you one homework. And before we talk about homework, let's talk about Vedantu's platform for 2 minutes. Vedantu's JEE and NEET platform is the best if you're preparing for JEE and NEET. Okay, if you are in class 11th or 12th, this platform is just for you guys. If you take a pro subscription, what do you get? You get full access to all the live courses. You get to choose the language in which you want to study. You get unlimited in-class doubt solving. You get to learn safely from home on any device you want. And you get all the best teachers of India, all of them having more than 5 years of experience. Okay, so if you want to take the pro subscription, how much will it cost? How much will it cost? Guys, if you take it for 1 month, it costs 6,999. If you take it for 12 months, it costs 31,800. But let me tell you a secret. If you use my coupon code, I will get you 15% extra discount just because I like you guys so much. I really, really like you. Okay. So go to, if you get the 15% discount, the price comes down to 27,030 and 5,949. Okay, so how do you take the how do you get the subscription? If you want the pro subscription, you go to vdnt.in/ytpro and use the coupon code AAPPRO. All right. Also, at the same time, if you haven't joined our Telegram group, please join our Telegram group. I am going to add notes on the Telegram group. People are telling me that, sir, you cannot see the annotation in the notes. Do not worry. I will add the notes with the annotations. Do not even worry. Okay. Anyways, thank you so much, Dhanush. Thank you so much, guys, everybody, for being here. Okay, I am going to stop this lecture now, and for 2 minutes, I'm going to stay here. If you have any doubts, you can ask me those doubts on the chat. Okay, for 2 more minutes, I'm here. You can ask me any doubts. Okay. Oh, Mahinder, you're most welcome. You're most welcome. Please keep coming here every day, guys. Get your friends, get everybody. Okay. All right. Any doubts? Any doubts? Any doubts? Any doubts? Okay. Homework. I will give the link. Homework I'm giving. Okay. Pim particles के पीछे का क्या राज है? Vulcan, I will tell you that in the next class. Okay, be sure to attend the next class. We will talk about pim particles in the next class. Okay. Okay. Will you not put questions of KVPI? Raihan, this series right here is aimed at JEE Main, so we will focus on that. If you want KVPI series, we'll start it maybe a little bit later, not right now. When will we solve numericals? Anshu, I will give you numericals to solve as homework. And what happens is that after a while, you can solve those numericals, and we will have a discussion day on Sunday or something. Okay, so that's how we'll go for that. Okay, homework questions I'll give. Dhanush, homework questions I'll give. Dhanush B 2022, I will give you homework questions. All right, guys. Okay. If you have any other doubts, if you have notes after session, Kaushik, I will share the notes. Okay, do not worry. Okay. All right, guys. So I guess that is it for today. That is it for today. I will stop here. If you have any doubts, guys, you can write it in the comment section. You can write them in the comment section. Okay, I will answer them. I reply to comments these nowadays. Okay, and before you go home, please do this question as a homework. Okay, and write your answer in the comment section. Write your answer in the comment section. Whoever does it first, I will take his or her name in the next class. Okay, yes, smart book, I will give DPP. Do not worry. Okay, note down this question, guys, and give the answer in the comment section. I will give you, please be fast. If you do it first, I will take your name in the next class. Okay, all right, guys. Okay, important questions, Dhanush, I will send in the telegram. Okay, bye everybody. Bye, bye, bye. Thank you so much for attending. I will see you guys in the next class. Okay, bye.